So now we're going to look at the inclusion, exclusion rule. So before, when we were counting, we used the addition rule because we had events that were mutually disjoint. So for example, like passwords of link 3 and passwords of link 4, there's no overlap there. But now we're going to look at two sets, A and B, and we're going to assume that they possibly have some things in common. So I'm going to draw what's called a Venn diagram to represent these sets. So here's my set A, here's my set B, represented by these circles, and then if I look at this middle part here, this is the overlap. So this would be A intersect B. And if I take the union, it would be the shaded in region here. So this would be A union B. And I want to count how many elements are in the union. It's the number of elements in A union B. Well, I can take and add up the number of elements of A plus the number of elements of B. But then the elements that are in this intersection, they got counted twice. So I've double counted, so I need to subtract the number of elements of A intersect B. So this is how we're going to count elements in the union of two sets. What if we have three sets? Well, our Venn diagram will look a little bit different. I have three circles, A, B, and C. And again, I want to count the number of elements in the union of these sets. So the number of elements in A, union B, union C. Well, I start by counting the number of elements of A plus the number of elements of B plus the number of elements of C. But then some regions got double counted. So if I look here, this region got counted twice. Got counted and counted. So then I have to subtract off the number of elements of A intersect B minus the number of elements of A intersect C minus the number of elements of B intersect C. But then I didn't actually count this middle part here. So I need to add back in the number of elements of A intersect B intersect C. And this would be my formula to count the union if I had three sets.